Hi everybody. Today we're going to look at simultaneous equations. Simultaneous equations are used to solve problems where we're trying to find where two lines meet. Where lines meet is called the point of intersection, and in the case of this graph here, the point of intersection is point A. Now we can easily find point A if we understand how to use simultaneous equations. And within simultaneous equations there are two methods. There's the substitution method, which is used when we can easily make one of the variables the subject of an equation. And the second method is called the elimination method, and that's where we can easily line them up and eliminate one of the variables. So let's have a look at the two techniques. Substitution method has 6 steps. The first step is to label each of the equations. Then we rearrange one of the equations to make one of the variables the subject of an equation if required. Often it is given to us in the problem. Step 3, we substitute the rearranged equation into the other equation. We then solve the equation, substitute the solution into one of the equations, it doesn't matter which one, and then state the solution. Very complicated sounding, but once you've done a few of them, it is relatively simple. So here's an example. Find the intersection of y equals 2x plus 1 and x plus y equals 5. So step 1, label the equations. So I wrote y equals 2x plus 1 and called it equation 1. And then I labeled x plus y equals 5 and called it equation 2. Now we look at these two equations and we see, is one of the variables the subject of the equation? And in this case, y is already the subject of the equation, so we don't need to rearrange it. We're just going to use that one for step 3. Now we're going to state what we're going to do. We're going to substitute 2x plus 1 where y is in the second equation. Thus I've said here, substitute 1 into 2. So where y is, I've now put 2x plus 1, and step 4 is then to rearrange this equation until I've solved it to find out what x is. So what did I do? X plus 2x is 3x, subtract 1 from both sides, 5 becomes 4, I get left with 3x equals 4, divide both sides by 3, I get x equals 4 on 3. Which takes us to step 5. Substitute x equals 4 on 3 back into one of these two equations. Which one did I use? I used the second equation. Probably in hindsight it would have been easier to use the first equation, but it doesn't really matter which one. So I should really state here what I'm going to do. So the missing step here would be substitute x equals 4 on 3 into 2. Always tell the marker what you're intending in case you make a mistake. So 4 on 3 goes where x is, there it is there, plus y equals 5. Rearrange, subtract 4 on 3 from both sides to make subtracting easy for thirds. I just multiplied this by 3 on 3 to give me 15 on 3. 15 on 3, take 4 on 3, gives me 11 on 3. Step 6, state the solution. If you don't state the solution, you're often throwing away marks, so highly advise doing it. 4 on 3 is x from here, 11 on 3 is y from here. Done. And that's how you do a substitution method problem, and they don't really change much from that. Elimination method has one extra step. So in elimination method, we're looking to see if we can make the two equations line up neatly underneath each other. But like the first method, we first have to label both equations as written in the question. Step 2, we're going to rearrange the equations to make x and y and the constants align. Step 3, we'll multiply the rows such that x or y terms can be eliminated by adding or subtracting. Step 4, we're going to do the addition or subtraction to eliminate the variable. Step 5, we're going to solve the resulting equation. Step 6, we're going to substitute the solution into one of the equations to find the solution for the remaining variable. And step 7, we're going to state the solution. And although 7 steps to solve something sounds difficult, when we're doing it, it's all quite intuitive. So, step 1. Take the equations, write them down, label them. Step 2, rearrange them so that all the x's align, all the y's align, and all the constants align. So you can see here in equation 2a, I've just taken equation 2, put the x's under the x's, put the y's under the y's. Now, with these two equations, it's not easy to eliminate them because we don't have two x's here to add them together to make no x's. We don't have two y's here to subtract them to make no y's, and we don't care about the constants at this point. It has to be one of these two that we're eliminating. So what we can do is we can multiply 2a by 2 to make equation 2b, and then we'll end up with positive 2y here and positive 2y here, and if we subtract the two equations, we're going to eliminate the y's. So, done that here. Done that here. 2x times 2. 2 times negative 2x gives me negative 4x, 2 times y gives me 2y, 2 times 4 gives me 8. Now, what I'm going to do is I'm going to take equation 2b, which is this one, and I'm going to subtract equation 1 from it. So, negative 4x, take x, gives me negative 5x. 2x, take 2y, take 2y, gives me no y's, which is now eliminated the y's. And 8 take 3 gives me 5. I'm left with this new equation. Now, this new equation, negative 5x equals 5, can be divided by negative 5 on both sides, which will leave you with x equals negative 1. X equals negative 1 is one of the solutions where these two intersect. In fact, it'll be part of the only solution. Once we've done that, if we substitute x equals negative 1 into either of these equations, we can find the corresponding y-coordinate. In this occasion, I've substituted it into 1, and I've stated it here, as I should have done the first time. So negative 1 plus 2y equals 3 by putting negative 1 in there. That's how this equation was formed. Added 1 to both sides gives me 2y equals 4. Divided both sides by 2 gives me y equals 2. Now we have our two values. We should state the solution, which is step 7. The point of intersection is at negative 1, 2. And that's how to solve a simultaneous equations question using the elimination method. So just to be clear, you would usually use substitution method when you're given an equation or can easily make an equation with either x or y as the subject of the equation. You would use elimination method if you can easily see that you can line up the variables, as we did here with 1 and 2a. I hope that helps, guys, and I will speak to you in the next one. Thank you, everyone.